Hey everybody, I want to talk to you about how to make random data in Excel and Sheets. It's quite easy, and it's going to turn out to be really helpful for understanding sampling distributions, which is what we want to do. So let me go ahead and get started here. So I'm just going to pop right into Sheets. And the first command I want to show you is the most important one here, which is rand. It's just equals rand. Oop, hello. Equals, there we go, rand. Sorry, I don't know what's going on there. And it makes a random number between 0 and 1. Here, let's call this up. So random number between 0, 1 inclusive and 1 exclusive. So meaning it'll include 0 but not 1. So yeah, there we go. Equals rand. That makes a random number. If I want to make a bunch of random numbers between 0 and 1, I want to use the fill command, which you can use. I actually don't know where the fill command is in here. It's somewhere. But the way I do it is this. You just grab on this corner here. So I want to point this out. Normally, I've just got mouse pointer. And if I like grab multiple things, it doesn't change anything. But when my mouse hovers over this lower right square, it turns into like a skinny plus sign, and then I can just drag that and it'll fill. There's some technicalities to the fill command that I'm not going to worry about right now, but that's what it does. It fills up the spot you specify with commands or simple commands. So anyway, I made a bunch of random numbers there. Now this is drawing from the distribution, the uniform distribution, right? So we know that this gives us a distribution that looks like this. It's going between 0 and 1, right? So 1, 0. This is the distribution this is drawing from. We know about the uniform distribution. It's one we've used before. The classic example for that, which was random number generators, which this is. So what if we want something like random numbers from a normal distribution, right? Like, let's say I want this distribution. Well, I can use the rand command in a clever way. So we need to talk about the inverse distributions. So firstly, you know how CDFs work, right? Where you specify a number, right? So here's my number. And then if I do normal CDF in the calculator, normal CDF of minus infinity up to k with the mean and standard deviation given, then what that'll give me is this area. So there's an inverse command called inverse norm. And that Sheets and Excel have it as well, although they call it something different. So if I do inverse norm, I put in the area. So I'm going to call this area A here. Inverse norm of A with a mean of mu and sigma. So normal CDF gives me A. If I do inverse norm of A, this gives me K. So here's the idea. Normal CDF tells you, it takes in a value, like an X value, and it gives you the area up to that value. Inverse norm takes in an area, and it tells you what K that area ends at from minus infinity. There are similar commands in Sheets and Excel, so let me pop back there for a second. And they are norm.inv. So equals norm.inv, right? Inverse normal distribution function. So let's finish typing that one in there. And so look what it's asking for, X. So this is the area right here. So if I do inverse norm, so norm.inv of 0.75, this will tell me the X value in the normal distribution with a mean of 1 and a standard deviation of 4 that would have cumulative area of 0.75 from minus infinity to that value. So here, let's type that in, 0.75. 1, 4. Sure, I'll use that example, right? And so this tells me that if I did normal CDF, so if I do norm dot, oops, I forgot the equal sign, norm dot dist of C1 with a mean of 1 and a standard deviation of 4 and a cumulative of true, thing it'll give me is 0.75. Right, so what it's doing is it's saying this X value gives me this area if I go minus infinity up to that. So here's what I can do. If I want to generate numbers from a normal distribution, what I can do is tell it to do norm.inv, but put in, instead of an X value, I put in a random value. Then what it'll do is it will generate some random number from the normal distribution. So this is what I mean. So instead of doing norm.inv of a number, oh, and by the way, notice these keep changing. Every time you do anything, it recalculates your random numbers. I'll show you how to get rid of that in a second. So if I do norm.inv, inv of, and then instead of an X, I'm going to put rand in there, right? That tells me that my X is going to be some random number with a mean of, say, 1 and a standard deviation of 4. Actually, let me do a mean of 0 and a standard deviation of 3, something like that. Just so it's centered around 0. I'll show you why in a second. All right, it gave me one number. Now, how do I know that number came from the right distribution? I don't actually, right? Because normal distributions span the whole number line, so it really could be any distribution that I'm drawing from. So let's see what I can do here. I'm going to fill this down to about 100 or so. Just generate 100 random numbers. 108 is fine, whatever, that's okay. So there I've got a bunch of random numbers, right? I've got 108 random numbers. And to show you that it's coming from the right distribution, which remember I was thinking of as the normal distribution with a mean of 0 and standard deviation of 3, I'm going to make a histogram of that. And lo and behold, that's about what it looks like, right? It's centered around 0. It's got a standard deviation of something pretty big, right? So 8.5 is the top and -7 is the bottom. Well, if you remember, 3 standard deviations gets you 99.7% of your data. So usually your highest and lowest values are going to be in the general vicinity of 3 standard deviations away, which this is, right? 3 standard deviations would be 9. So this is a little bit smaller than 9, and this is a little bit smaller than -7, or a little bit larger than -7. So this is very plausibly the normal distribution with a mean of 0 and a standard deviation of 3. We're going to use this technique of making random data from distributions to sort of see what they look like. And I'll show you what we mean by that in a different video where I talk about what a sampling distribution is and how we can sort of visualize them. But for now, just realize that that's what we're doing. And so the technique for doing this is to use the inverse function from of the distribution that you want and put a random number into the probability or into the area. And what that'll do, well, let me explain a little bit. Yeah, let's explain a little bit here. So let me go back to my whiteboard and get a new page. So if I have a normal distribution, that one that I just specified with mean of 0 and a standard deviation of 3. Right, so here's 0. And I make a random number. And what it's going to do is a random probability, so a random number between 0 and 1. So we're thinking of that as probability, right? The area under this is between 0 and 1. So it gives me a random number of like 0.1, right? So 0.1 is to the left of this area is 0.1. And if I do 0.2, so 0.1 is like this whole infinitely long region is 0.1. If I do 0.2, well, it's going to give me something like this. And the reason it's going to do that is that this area is 0.1. And then this area right here, everything to the left of this thing that I'm calling K is going to be 0.2. But this additional 0.1 is relatively small. right? That change in X to get an additional 0.1 of area is relatively small because the distribution is thickening so much, right? It's getting taller. If I do 0.3, it's going to be even smaller, right? The change, I'm not doing this very accurately, but it'll be even smaller, right? Then this area is another 0.1 and you'll get 0.3. And so what'll happen is the amount of X's in this region and the amount of X's in this region and the amount of X's in this region are all going to be the same because the probabilities are the same and our random number is being interpreted as a probability. So what that means is in the tall areas of the graph, here, you're going to get a very high concentration of X values that give you those areas because a small change in X gives you a relatively large change in probability or area. So what ends up happening is the lower the graph area, over here, it's all very skinny. And you don't get that many, you get a much lower concentration of the X's, which is exactly what you want, right? The height of the curve corresponds with the probability. And so since your frequency of X's in that region is much sparser, they end up being lower on the graph. And conversely, you end up with something much higher on the graph in the very thick or tall regions, which is exactly what you do to recreate exactly what you do to recreate the normal distribution, right? You want lots of things in the tall areas and very few things in the shorter, skinny areas, because that's how frequency works. So that's why this works. I don't know if that explanation was particularly understandable. I feel like even as I was saying it, it sounded confusing, but it is true. And I'll let you just think about it, consider it, and consider why that's true. But that is why this works. And so we can make random data from a bunch of different distributions. And by the way, this is how I make those like skewed graphs that I put on tests, or normal distributions that I put on tests, where I make a histogram out of stuff and say, well, here's some data. This is exactly what I'm doing. I'm just doing random probabilities in my norm inv, or as I will show you a couple other ones. Why is this doing this? So there's a few other distributions that I'm going to use. I'll show you chi-square f. Maybe that's enough. There's a few others. My battery's running low. Let me plug in my computer here. Sorry. All right. So chi-square and f are they're both skewed to the right. So if I do equals, I think it's chi inv? Yeah, chi inv of rand. And then degrees of freedom is the thing that we haven't talked about yet. I will just tell you that chi-square is right skewed. Its minimum value is 0 and is skewed to the right, so you'll get outliers on the right. And whatever your degrees of freedom are that's what the average is going to be. So if I do 5, and we'll make a bunch of these, and I'll show you after this how to, that ought to hold me. I'll make a histogram out of this. There you go. You can see that the peak is a little bit before the average because there's outliers on the high side, right? It's skewed to the right. So the average here is around 5. And if I found the average of these values, equals average of column E, right around 5, right? Yeah, so no thank you on that. And the constant changing is annoying me a little bit, but you can see what this looks like, right? So if I want to generate a chi-square distribution, I can do this. I can choose my degrees of freedom to be whatever I want. And then there is another one that I use that's very similar. It's going to look superficially similar, but it's not, or it is similar, but let's see here. It has 2 different degrees of freedom. I'll go 5 and 10. And these are not the mean. those are something else entirely. Don't even worry about what they mean for right now. The average of this is going to be around 1. If I graph this, right, so you can see skewed to the right, you get the average is again around 1. It's quite small, and it's right skewed. So if I want to generate random data that looks skewed, I can do this. So let me show you how to stop it from changing all the time. It's a little irritating to do this. Excel does the exact same thing. I don't know why. I'm gonna go ahead and delete this. But if I want to just make some random data and then fix it and then not have it change every time I do anything at all, what I'm going to do is I'm going to copy paste. Now, if I copy, so I've copied this. If I right click and go to paste, it's going to put in everything, including the formulas, and it'll keep changing every time I do anything. But if we go to paste special and paste the values only, it will get rid of the formulas, but keep the numbers, right? So now notice these don't change whenever I do anything, right? Equals, right? So those all changed, and then this one didn't. So this is how you fix values. You just copy paste and paste special values only. This is also how you do it in Excel. I think there's other ways to do this, but this is the most convenient one that I know of. Okay. One last thing is how to transform these values. I'm going to go ahead and delete everything here just because I don't want them right now. And let's say I want a random number between, let's say, 0 and 10, right? So Rand doesn't do that. I can't specify numbers between 0 and 10. Like that's not a thing. There is a rand between command, but it gives you a random integer. It won't give you decimals. And between like 0 and 10, it'll give me only integers, not it'll choose 0 or 1 or 2 or 3, but not 1.5. What you can do if I want a random number, not just a random integer between there, I can do the following. Here's the idea. Well, let me just show you. I was going to share up a whiteboard, but let me just show you how to do it. So I'm going to do, so since rand goes between 0 and 1, if I wanted to go between 0 and 10, I can just multiply the whole thing by 10. Because you take the 0 and you multiply it by 10, that gives you 0. Take the 1 and multiply it by 10, that gives you 10. So now that equally spaced distribution between 0 and 1 gets stretched out to 0 to 10. So if I do equals 10 times rand, now it gives me numbers between 0 and 10. Hello? Why won't it? What is it doing? There we go. Sorry. Now it gives me numbers between 0 and 10, which is what I wanted. If I want numbers between, let's say, 5 and 23, what I can do, so let me do this. I'm going to try to do between any two numbers you want. So let's do like -5 and 23 instead of +5. So rand goes 0 to 1. 0, 1. If I do 10 times rand, that goes 0 to 10. Well, what I can do is I can like add or subtract things. So let's say I want to end up between 5 and, or I was going to do -5. I'll just show you how it works with negatives as well. So let's say I wanted to go -5 to 23. But I wanted numbers between there. Well, what I can do is I can shift these numbers around. I can shift this distribution around by adding or subtracting to it, or adding or subtracting from it. So what I really want to do is I want to think of, okay, I want to first put my left edge at 0. So I would need to add 5 to this whole thing. So I'm saying that backwards. I want to subtract 5 from the result so that it shifts left. It's going to go 0 to whatever, and then it's going to shift left 5 units. So I want to do something -5. And then these numbers are 28 apart. So I would want to do 28 times rand minus 5. And what that'll do is it will take the 0 to 1, turn it into 0 to 28, right? That's what the multiplying by 28 does, and then shift that left 5 units so that it's going minus 5 to 23. That's the idea. So if I do 28 times rand minus 5, I will get a uniform distribution between -5 and 23. So let me show you that that actually works. So if I do equals 28 times rand minus 5. All right, so do you know that's the right distribution yet? Not yet. Hey, there we go. But if I make a big old histogram of it, right, so let's make a histogram and see if that looks like a uniform distribution between -5 and 23, and it does, right? So not quite, right? So it looks like it might go up to 25 here, but it doesn't, right? The last bucket that has anything in it ends at 23.13, which just means there's something very near 23 in here, and this goes down to -5 here. So, and by the way, uniform distributions, when you make them randomly, do look like this. I know the actual distribution is flatter than this, but this really is what uniform distributions look like if you generate them randomly. This is what random data looks like. It's just kind of jaggedy, no real peaks, right? There's sort of a peak here, but it's really just a random chance that you end up with a peak in there, not some property of the distribution that's causing that. So that's how you can make random data, or a uniform random data from a uniform distribution between any two numbers you want. You take the 0, 1, you stretch it to however wide you want the distribution to be, and then you shift it left or right to wherever you want to put the left end, right? Remembering that the left end starts at 0. So if you want to make it 5 to 10, you have to add 5 to it, so it shifts over 5 units. Yeah, I think that's all I want to say about generating random data. We are going to do a bunch of this in your homework. I asked you to do a little bit of it, and then also to visualize sampling distributions. This turns out to be relatively useful. So I'm going to go ahead and stop there, and I will see you guys in the next video.